So this is the third part of plotting, of taking global vaccination data for COVID and doing simple plotting so we can do some pretty graphical things, okay? And we're going to generate a little chart like this, and today is code day. So today we are going to look at the Python code required, and we're going to do this in a Jupyter notebook. We're going to look at the Python code that's required, the simple code to make this thing work. So we get data from our world of data, right? And they have all the pandemic data here that they have collected, and they actually put it up on GitHub. And we're going to use this repo. And basically what we're going to do in part 2, we talked about how we take the top half of this data that doesn't align with each other and is missing values, and we fill in the missing days, and we synthesize or interpolate the rows, and we decide what we're going to do with that, and then we plot it. And so as we talked about the other day, we're going to load the data in through a notebook. We're going to create some records for the missing days. See video 2. We're going to interpolate the data where we have data rows missing in the middle, because not every country returns data every day, or they return data but not all the statistics. So we're going to interpolate the values. And then we're going to fill in the string columns. And I had an example here. You can see that we filled in the www. This is the website that the data came from. And so we were able to put that everywhere because it's a constant. We always get that country's data from the same place. And then we're going to create charts. And then just same thing. This is updated for yesterday. Basically, we have 3,679 rows of data for all the countries. And then we're going to post-process that and fill in the missing rows. That'll actually jack us up to 6,831 rows. And we will go from 1,300 rows with vaccinated per 100, which is what we're plotting, to 1,800 rows. So we almost doubled the number of rows we build, but because of the way the data was laid out, we only went up about 50% in the amount of data that we're going to put in the pretty picture. So let's go look at the code for this. This is a Jupyter notebook, and the code is super straightforward. It's kind of disturbingly simple. All right, I closed out 2 of the cells because it's basically some logging code. All right, so first thing we're going to do is we're going to load the data, and then we're going to print a list of the unique country codes. But basically, this line of code here, can I even make it bigger? Yeah. This line of code here loads the data, and then it turns out the data has dates in it, and the dates get loaded as strings. So we convert the date strings to date objects. If you have debug enabled when you run this notebook, you'll actually see the data model before and the data model after. So we loaded the file now. You can see number 4, we've loaded the data. The only parts that were important were load the data, convert the data. Everything else is logging with debugs enabled. The countries don't supply data for every day. So what we're going to do, the only part that's important in here, everything else is logging, is we're going to take the loaded data set, we're going to sort it by date and country, we're going to unstack it, then we're going to fill in all the missing rows, okay? And then we're going to restack it, and we're going to leave NAs in any of the cells that we built. So all the synthetic cells will have NA instead of having 0 in them. Okay, so we're going to run that. All right, and what it said was, hey, we originally had 3,679 rows, and we had 3,500 that had daily vaccination data, 2,400 that had total vaccinations, 1,367 that had calculated vaccinations per 100. In theory, if we knew the population, we could calculate more of these, but I'm sticking with our world of data and only interpolating for this. A real data scientist would do more. And then after adding the missing rows, we went from 3,679 rows to 6,831 rows. So we added about 3,200 rows. Okay, and we didn't fill anything. So the number of rows with data is the same, and the number of rows that are empty went up by the number of rows that we added. And now we're going to fill in the missing values. So this filled in the missing rows with no values. This cell will fill in, interpolate. See here, there's interpolate on the right. All the numeric cells are going to be interpolated. All right, and then all of the text cells that we want to keep. So there's actually more columns here. I just didn't need them all. So I filled the ISO column. So we had the ISO country code as a constant. I could have done the website too. I can't remember which data set this is. Anyway, so we have the country name and the country code basically. And so I filled in the country code, but I interpolated all the numeric values. So if we were to come here, now we have 6,831 rows, which we had before, but you can see that we have in daily vaccinations, we have 3868 that now have data. And prior to that, we had 3542. So we went from 3542 with data to 3868. So we added some rows of data to that. And that really the reason we're doing that is we're going to make the plot prettier. So that's it. All this does is interpolate the fields I want, and then we've got some fancy logging here, right? And that's it. So now our data is completely prepped, and we can run the plot. So this actually takes a while. All we're going to do in the plot here is on the x-axis, we've got daily vaccinations. How many vaccinations per day? We'd like to see this graph move to the right over time. And y is going to be fully vaccinated per 100. And we're going to animate this. We're going to see the vaccinations move up as we get more people vaccinated per 100. And we're going to animate by country. So the individual dots are going to represent the country. All right. And then the rest of this, I did a log. This actually exaggerates the progress countries are making in the beginning, and it compresses how bad the problem actually is. Actually, you know what? I'm going to do this one too in a minute. So this one's still running. So the plot actually takes longer than the data, right? I'm going to go back while we wait. So we loaded the data right here. We loaded the data. We changed the date type. We added the missing rows. We interpolated the numeric values and filled any of the interesting string values. And then we plotted it, and we got this. And this is a log plot, daily vaccinations against fully vaccinated per 100. And if I were to move, you can see not much is happening here before the beginning of the year. And when we start to see countries move in, right? And then we can see as this moves right, as this moves right, we can see countries moving up, right? So like this is the United States here. We can see actually that red dot over time, you can see it moving up, right? You can see a lot of the countries moving up. And you can highlight over any of these and it'll show you what fields we put in this. And that's it. There's a non-log lot, that one's not done yet. We loaded the notebook, we created the missing rows, we interpolated and then we filled the text values, and then we created the charts. And that's it. Go to this repo if you want to see this code. Have a great day.